Hey, what is up guys? My name is Cherno. Welcome back to my OpenGL series. So, we are back. Last time we talked about creating this whole test framework and test classes and all that, and we had something where we could actually create test classes which extended like kind of a base test class, and we could kind of demonstrate each individual OpenGL feature or whatever we wanted to really do with OpenGL in kind of a sandboxed test environment that was really clear for us to kind of, I guess, demonstrate and have samples of the various features that we learned about in OpenGL and just various kind of, I don't know, graphical tests. That's the kind of stuff that we're going to use it for in the future. So if you haven't seen that video, then definitely check that out, because today we're going to be extending that. And last time I gave you guys a bit of homework to figure out how we could create some kind of test menu where we could click on a test and it would construct a new test. And then when we went back to the main menu, it would kind of delete that test, unload all the resources, and then kind of present us with that test menu again. And today I'm going to show you one of the ways that we can actually implement this. So thank you to all of those people who shared their solutions. I think most of them were shared on Discord. So if you guys haven't joined my Discord, then it's it's the cherno.com/discord, and then that's kind of the invite link. It's just a great community of people where you can talk about all kind of aspects of programming, development, graphics, games, whatever it is you want to talk about. All that stuff is there, so definitely join that community if you haven't already. Anyway, let's just dive into some code and check out a way for us to create that test menu and have it kind of construct and destruct class instances for us. Okay, so jumping into the application.cpp file that we have. If you guys don't have access to this yet, by the way, definitely go to patreon.com/thecherno. Help support this series. It really does help me make more videos for you guys, and you'll also receive all of the code kind of episode by episode as separate commits on GitHub. So definitely check that out and help support the series. This is the code from the beginning of the test framework episode. And if we take a look at what we have here, essentially we already have this test that we're kind of presenting, this test clear color. But what I'm actually going to do is start off by just going to this test folder and adding a new item. And it's going to be, actually, you know what, we don't even have to create a new file. We're just going to do this in the test.h header file. And we will need a CPP file because I do want to separate the implementation. So I will create a CPP file called test.cpp. And over here, still in this namespace, I'm going to create this test menu. And this test menu class is going to have, it's just going to be a test really. So if we implement, or rather extend the test class here, and then we'll have pretty much all of this stuff. So I'll just copy and paste that over here. I won't implement this, and I'll just mark it as override, override, and override. The cool thing about this, by the way, is that because I didn't make them pure virtual functions, let's get rid of this. Because I didn't make them pure virtual functions, we don't actually have to override the ones we don't need. So this is a great example. I think someone asked in the comments below why I didn't make these functions pure virtual, and I would do that by just writing =0 like this. The reason I kind of left them as just virtual functions and implemented them with a blank body like this is so that we could selectively choose which ones we actually wanted to implement ourselves. If they were =0, if they were all pure virtual, I'd have to have all three. But with this method, I don't actually want on update or on render, so I don't need to have them. I can just go ahead and delete them, and then everything will still work fine. I don't have to implement them. It's just an option that's given to me. So this test menu class is going to do two things. First of all, it's going to contain a collection of all of our tests, and we want a way to be able to basically, I guess, present them with a specific name. So we need a pointer to a test class, a test instance, I guess, a test object instance, but I also want to store a name that we can provide for the test, so that's kind of the label, I guess, that appears for our button in the test menu. So what I'm going to do is create a vector of std pair, and we're going to have a pair of string and the actual test pointer like this. Now here's where it gets a little bit interesting. I don't actually want a test pointer because that implies that the instance already exists, which would be great if we kind of went with the strategy of I just want to create all of my tests at the beginning of my application and then add them to my menu, and then like switching to them would activate them maybe. But I don't actually want to do that, because what I'm doing, right, is I've got my constructor and destructor. So what I actually want to happen is when I press the button, I don't want it to just activate a test instance. I actually want it to create and construct a test instance. I literally want it to say new test. And when I kind of go back out of that test, I want it to delete the test. So I can't just add a test pointer, because a test pointer of course, would be a pointer to an already existing object. What I need instead is a way to construct that object. And one way that I could do that, which is what I'm going to do now here, is I could actually just provide it with a lambda. I could provide it with a function that constructs that, that test class of mine. So if we go back here, I'm going to make the second element of the pair here an std function of just test pointer here. And no parameters. So this basically means that this function returns a test pointer and does not take any parameters. So this is basically going to return new test, depending on which test we actually create. And then that's going to be my vector, and then I'm going to call this tests. Okay, so I need one more angular bracket here. And I'll include functional so that I get access to the std function class. Okay, cool. So there we go. I've got a vector of pairs, and each pair contains a string and a function which returns a test pointer and takes no parameters. Okay, so I could have created a struct instead of creating an std pair, but this is actually rather trivial. I don't really want to create a whole new type in a new struct called, like, I don't know, test. I don't even know what I call it because I've already got tests. So maybe like test menu instance or something like that. I'm not sure. There's no need to create anything like that. We can keep it kind of anonymous because we know here that basically this is just a list, right? A vector of strings and the actual test classes which those strings kind of create, because the string is just there because we want to give our button a label. This will all make sense when we actually see it on the screen. Okay, cool. And then one other thing I actually want is a pointer to the current test. Now the reason we need this is because our menu is going to change the current test that's active. Right now in application, we don't have a current test. We've just got this. What I'm actually going to do here is have an actual test pointer, which is our current test. Okay, I'll just call it current. This is what we actually need to modify, and we want the test menu to actually do that for us. Now we could, again, pass in some kind of lambda or something which modifies this, but an easier way is going to be just to pass in a reference to that test pointer, and then this test menu is actually going to be able to write to that pointer and thus change the current test. So in the constructor here, we'll pass in that, I guess we'll call it current test pointer. And then if we right click here, actually let's go back to that CPP file so I can include test.h, and we'll put in namespace tests, and then we can go back here and implement everything we need by creating the method implementations. Okay, cool. I don't think we need a destructor actually, because everything's stack allocated anyway, so we can get rid of that destructor. And then this is great. It didn't really do what I want. That's because it's the test namespace, not tests. So we'll get rid of that and that. Okay, so constructor is going to set current test to current test pointer like that. And then on ImGUI render is going to actually render that list that we have. So I'll just say for auto, and then this will be, I guess, test in our tests. What we're going to do is actually create render an ImGUI button. Now, okay, what's going on here? std no, okay, so we need to include a vector. Oops. Okay, so inside this tests, we're now going to basically render an ImGUI button. So we'll say ImGUI button. The label is going to be that test. Now this is a pair, don't forget. So test first, and this will just be a dot visual assist. Thank you. Dot C string, because it wants a C string, wants a const char pointer. And then, of course, if that button is pressed, we basically want to execute what that button says to do. And that button, what that button says to do is that actual function. So we really just need to call test.second like that, because it's the function we want to execute. Now we don't just need to call it. This returns, remember, this returns a test pointer. This returns the new test pointer that it's supposed to construct for us. So that's what we actually want to set current test to. So current test gets set to that lambda that constructs our actual test class instance. We haven't actually created that lambda yet, that function, but we will in a second. Let's include ImGUI here because we need to. Okay, cool. There we go. So that looks pretty good to me. So we should have a list of buttons, and if we press the button, then it will hopefully change that current test pointer to be whatever this test actually returns as its kind of creation function. Okay, cool. That looks pretty good to me. Let's go ahead and create that test menu. I'll go ahead and include it over here as well. So actually it should already be included because it's in the test.h header file. So we'll say test menu equals new test menu. We're going to pass in this current test. I'll actually call this current test just so that it's a bit more explicit. By default, we'll set this equal to null. And then when it does get created over here, we'll set the current test equal to menu because we want it to basically start off with the menu. Now at this point, you could add some kind of command line argument or something like that if you wanted this application to boot up already with a specific test. This is very useful if you're actually trying to test something, because if you're actually working on a test or working on a new OpenGL technique or something, or trying to implement something, whatever it is, and it's implemented as a test, you don't want to have the menu come up every time and then you have to click on it. So every time you debug your code, menu comes up, then you have to click on it, menu comes up, have to click on it. That's a waste of time. So you can just get it to kind of open a test for you kind of from the get-go without having to go first to the menu. And instead of hard coding that to just go to a specific test or whatever, you could just have it as a command line argument. That's really nice if you're working in a team as well, because it means that instead of you accidentally checking in the code that sets the test to a specific test, the one that you're working on, you can just have it as a command line argument, which is technically stored kind of in your user settings and thus wouldn't actually be committed to the project. So yeah, you could do something like that if you like. That could be a nice homework task. So make it take in the name of a test as a command line argument and open that in maybe if that command line argument is actually set. Okay, cool. So we won't worry about this test clear color just yet. Now we are creating everything on the heap here, by the way, because we do want explicit deletion and all that stuff. So this test clear color or whatever will kind of change in a minute. Let's just make sure this works first. We have no way to actually add tests, and I'm aware of that. We'll fix that in a minute, but I want to set this up first. Basically, all we're going to do is when we start the new frame, we're going to say if the current test is not null, right? So if current test, then we're going to basically update the current test and render the current test. And then we're going to begin our IMGUI window, which is going to be just called test, I guess, which is going to be, we could actually set it to the name of the test, but we'll keep it as just test for now. On update, we'll take in 0, I guess, as our delta time. And then this is actually what's going to call, I guess, current test on render, on IMGUI render. Now, we are going to have to implement that back button that I talked about. Let's go ahead and do that now, actually. So if our current test is not the menu test, so it doesn't equal menu, I should probably call it test menu or something like that. Test menu, just so that we're not too confused here. I like to call my variables meaningful things, even if it does mean making them longer. So we'll call this test menu. So if the current test is not test menu, and IMGUI button, I guess we'll just draw a back arrow for now. So basically, we're going to draw an IMGUI button. I can't believe I drew that backwards. We're going to draw an IMGUI button, which is our back arrow, but that's only going to happen if the test isn't test menu, right? So I could nest these if statements, but I've just added them kind of side by side with an AND operator, which means, of course, this condition won't even be evaluated if this is false. So if the current test is not test menu, then we'll draw this button, and if that button is clicked, then that's when we get into this stage. So what we want to do is delete the current test, and then set the current test equal to test menu. And that is pretty much it. Okay, cool. So now we have a way to get back to our test menu. Really all we need now is a way to actually create kind of tests, right? So the way I want to do that is I'm actually going to add a function, and I'm actually going to kind of write the code as if the function exists already. A lot of people ask me what a good way to write kind of marginally complex code, or just how to write code really, when you're kind of not sure of, like, you know, you don't want to just start writing a function because you're not really sure what it's supposed to return, what parameters it should take. The best way to do that is just to pretend that the function already exists and just actually start by using the function. So in this case, I'm going to pretend that that function exists, and into test menu, I'm going to just write test menu, arrow register test. Now I want to register the test. I need to pass in the type, so this is clearly going to be a template. So I want to register the test clear color. And then of course I want to give it a name, so I'll just use a parameter for that. And I'll call it, I don't know, clear color or something like that, right? That's going to be our clear color test. That is now what I want the function to do. Okay, I now know the function needs to be a template, needs to take in the type. It needs to also take in the name of the test so that it can display it in the test menu, right? Because we have our test menu which displays those names as the button label. And then of course the actual function needs to create a lambda that creates a new instance of this class type. So it's really straightforward from now basically, because I've already created the function, I just need to implement it now. So it's going to be template type name t. It's going to be a void function called register test. It's going to take in a const string. Oh, I guess we can just take in a const char pointer. We are storing it as string though. So I guess we could take in a char pointer because of course we know that this actually, this imgo thing renders a char pointer, but I am converting it into a string, which is also fine because we might want to do some manipulation or whatever, and we should be using strings anyway. So I'll still keep that here. And then all this is really going to do is add that test into that list. So just mtests.pushback. Now we're going to have to make a pair here. So make pair. We're going to pass in that name. And then we're going to just create a very simple lambda. It doesn't need to capture any variables. That's just going to return new t. And that's it, because t is the type of class that we're actually creating. Okay, and then what's going to happen is, of course, as we call this register test class with every kind of different test type that we create, the compiler is just going to create a new version of this register test function in our code base that actually returns the new kind of class instance that we requested based on the type. Okay, one thing I will do is just quickly write, for our sanity, registering test, and then we'll kind of print the name, just because it would be nice to know which tests we actually kind of create, I guess. Or not really create, but register, because of course we're deferring the creation until we run this lambda, and we're running that lambda when we actually press that button to create it, because it gets run right over here. Hopefully all this is making sense. Plenty of videos for you guys to watch about this. Definitely watch the one on lambdas. I'll have it linked up there, because that of course is going to explain how lambdas work and how these kind of functions that we're creating that are getting called later, how that whole thing works. Also templates, another good video to watch. So in fact, just check out my CPP series, my C++ series, if you're not kind of sure what some of these things are, because I think I've covered pretty much everything I'm using in this video in that series. Okay, so we are pretty much good to go. We don't need to create this anymore at all, because remember, that actually gets created when we press the button. So let's get rid of all this. I think I've implemented everything. I'm not sure, because obviously I'm running the code right here live. So let's just hit F5 and see what happens. I say that very often. Let's just hit F5 and see what happens. I should get that on a t-shirt. Okay, cool. So we have this test, we have clear color, and then hopefully if I press clear color, look at that. It opens the clear color test. Shows us our clear color. We can change all of that. Everything works pretty good, I think. And then if I go back, we go back to the clear color test. Now in this case, you can see it hasn't actually changed the clear color, which makes me think maybe it hasn't worked, but I'm pretty sure it has. What I'm pretty sure has happened, because you can see it does go back, is that we're just not setting the clear color. So if we go back here, and do we have a way to set the clear color inside the renderer? I don't think we do. We've just got clear, right? So maybe into clear, we could maybe add another function called set clear color, and then this would take in, do we have a math library? We don't have a math library. Okay, great. Okay, this is going to be too hard, and I don't really want to do this right now. So if we go back to application, does CPP, we're just going to, when we clear the color, we're just going to set the color to black. So GL clear color, 0.0, 0.0, 0.0, and we'll set the alpha to 1, just like that. Okay, so now hopefully we should see that go back to black when we go out of the test, because that's how it should work. Okay, cool. So if we click clear color, we go there, we go back, it takes us back to clear color. Now it'd be fantastic if we had an additional test to actually test this out and see if it works properly, but we're going to kind of get into that as we start implementing more tests. The texturing tests and all that, I think next episode I'm probably going to create a bunch of tests and kind of divide out all the kind of concepts that we've learned right now into separate tests. So as we continue on with the OpenGL series, we will be adding more and more tests, but you can see that the kind of the basis of the framework is up and running. You can just add kind of multiple tests to this thing, and you'll have them all nicely appear in the menu, and they should be created upon creation, upon like actually clicking the button, and then destroyed when we destroy it. Now, there is a little bit of a memory leak, of course, because we don't delete the test menu or anything like that. So what we actually need to do here is, what I want to do is I need to delete the current test when we actually close the application. Now, you could argue that, of course, if we do close the application, of course, the operating system is going to clean up anyway, so we don't really need to do it ourselves. However, to be nice, we should still technically do it. So what I'm going to do is delete the current test when we actually close the application. So of course, when this while loop terminates, the while loop that is the GLFW window should close while loop, and we start to shut everything down and terminate it, I'm actually going to write delete current test. Now, here's the thing. And of course, this needs to be in this scope. Here's the thing. I also want to delete the test menu. However, if the current test is the test menu, I'll be deleting things twice. So if current test does not equal test menu, then we're going to delete test menu. Otherwise, current test already is the test menu, and thus we don't need to delete it. So we shouldn't get any crashes with this code. Let's just hit F5 and see what we can do here. So if we just close it right now, we should be fine, because it just deletes the current test, which is the test menu. And then if we hit F5 again, then we're going to go into the test, and if we close it now, it should kind of delete both the current test and the test menu, because the current test is no longer the test menu. Okay, anyway, I hope you guys enjoyed this video. If you did, you can hit that like button. You can also show your support by going to patreon.com/the Cherno. Great way to get access to all the code, of course, that I wrote today, and all of the other episodes as well. Huge shout out, as always, to all of my lovely supporters, because these videos would not be here without you guys. So I really am thankful for that, and your support means a lot to me. I will see you guys next time. I'm going to continue writing these tests. I'm going to write one for textures next time, and then from then on, of course, we can start learning more about OpenGL, and we'll have kind of a separate test class demonstrating all the stuff we learn kind of per episode. So I'm really excited about that. I'll see you guys next time. Goodbye.